These are your 9-3A homework help questions. You really don't need a graphing calculator today. You need your notes today. So if you did not watch your notes, that might be something that you want to take care of so that you can follow along. We are describing relationships of these things based on the fact that they are in what we call vertex form. And when an equation is in vertex form, you are looking at the vertex. And so if you want to put this at the top of the page, this will kind of help guide you. I'm not spending a ton of time on it because it has all been said in the actual notes. Okay, so it looks different. The other one was called standard form. This is vertex form, and your vertex happens to be the number sitting here and here. And so your vertex is what we call HK. So if you look at number one, I'm going to do a couple of these with you, and then you are on your own for number one. I'm going to just change this. I'm going to take the g of x to y equals, just to make it simpler. This actually is in vertex form. I can expand that out and call it x minus 0 squared plus 2. And now I'm in what's called vertex form. Okay, so if this doesn't have the parentheses, if you notice in number 2, it has the parentheses, but it's missing a number out here. So let's go ahead and put a plus 0 out here. Right, and then number 3, same concept, doesn't have any parentheses, so that x squared is technically telling you it's x minus 0 squared minus 8. I think it just helps to see those parentheses. It says describe how the graph of each function is related to the graph of the parent. The parent function is just x squared. Its vertex is at 0, 0, and so a does something, h does something, and k does something to these numbers. My a value in each of these is a 1. Okay, there's an actual 1 sitting here. And that's how wide or how narrow the graph is. The parent function is also 1. So the fact that we didn't change that number out in front tells me we didn't make it any skinnier or any wider. We say stretch or compress vertically. If it gets skinny, we're stretching it vertically like taffy. If it gets fat, it's like we sat on a ball and it squished out the sides. Okay, so stretch and compress vertically is our language there. So all this first one did is the only thing that changed is this plus 2 right here. And that plus 2 is your k value. And so it's a vertical translation. The graph went up 2 units. So this graph, it translates up 2 units. It didn't flip around. It didn't go sideways, and it didn't get skinnier or fatter. Translates the parent function up 2 units. Okay, now if you look at number 3 actually went down 8 units. So it's a translation. When things move, they translate. In middle school, we called it slides or glides. It translates down 8 units. Okay. I'll just kind of skip around here to number 5. For number 5, a couple things are going on in number 5. So if you look at number 5, I'm going to just expand that x squared again. So I've got y equals 1/5 x minus 0 squared plus 3. Okay, so a couple of things are different here from the actual parent function. This 1/5 right here. This 1/5 means kind of like a slope. So I'm going to go, not necessarily because it's kind of slope, because parallels don't have a slope, but if you thought about it, 1/5 would be up 1, out 5. And so it's going to make it wider. So when we make it wider, it compresses vertically, making it fatter, wider. And then the plus 3 at the end here, the plus 3 is also a vertical translation. So it translates it up 3. When you say translations, you have to say translates. You got to tell me which way, up, down, left, right, and how many. Okay, one more for you guys. Let's do number 7 here. Number 7 is everything, all of the above. Okay, so for number 7, that negative out in front, even though it's a negative, it's still a 1. So it didn't get wider, it didn't get narrower, but the negative is going to reflect it. Reflects over the x-axis. When you tell me the reflection, you got to tell me where, which way is it going? Right now, all you guys know is that it can go upside down. This is what means it's going to open down. So it reflects over the x-axis. The parent is facing up. And then there's 2 translations here. I'll kind of color coordinate them for you. The +5 we haven't done yet. The actual form says x minus h squared. So if the original form of the equation says minus, and we're looking at a plus, that means we plugged in a negative value. So this graph translates 5 units to the left. That's the hard part, that h value does the opposite of what it looks like. And then the +3 out here is true to its sign. And so it translates 5 units left and 3 units up. Okay? We're not going to do these graphs right now. We'll talk about those and do those when I return. And then there is the backside where it's matching. Okay, look at the numbers, look at the size, and try to figure out which one got skinnier, which one flipped, and try to make that connection using that language. But again, if you don't have the notes today, you're going to want to watch them. Your Chromebooks should be able and should be unlocked for that to happen. Good luck.